Hi, this is Sheik Mohideen Shah, research scholar doing PhD under the guidance of Dr. S. Meganathan, Associate Professor, Department of Computer Science and Engineering, Srinivasa Ramanujan Centre, SASTRA Deemed University, Kumbakonam. My research topic is power consumption prediction and energy forecasting using machine learning model. First of all, I would like to highlight what is the need of power consumption prediction. Power consumption prediction plays a vital role today in order to determine the demand. Next, power consumption plays a vital role in preventing the shortage. And we can also know the cost of a different pricing program. Here, the next thing I would like to highlight here is the power consumption prediction is based on rural, urban, suburban. My area of focus is rural domestic power consumption data. Here I have divided the power consumption with respect to unit, per day consumption unit. There is a range 0 to 500, 500 to 1000. I have divided them with respect to unit as band 1, band 2, band 3. So it is easy for me to classify in which band the power consumption is coming. This is the basic of my research. Next, I would like to move on to the overall architecture diagram of my research. First, the input is given with respect to consumption data taken from Tanjore, Tamil Nadu, Generation, Distribution and Corporation. Nearly 4,50,000 individual customer records all over the micro circle of Tanjore, that is called Tanjore region, is taken and it is pre-processed. Pre-process means data cleaning and handling the missing value. Here, as a result of pre-processing, I am going to select the best feature. That is called feature engineering. Feature engineering support temporal feature and statistical feature. Temporal feature refers to time-dependent data, that is time series data. Based on that, we can do the time-dependent distribution of data with respect to time series value. Here, I am using K best feature to select the top K feature. K represent the top features, top relevant features. Each and every feature is selected with respect to the rank. Based on the rank, which feature has the highest rank, that will be selected and the other features will be eliminated. Next, as a result of feature selection, I used to compare with the base learner model along with my proposed algorithm called SRVPC, support resistant value plane classifier. The meaning for support resistant value plane classifier is I am going to find the maximum and minimum value with respect to band 0 to 500, which is the minimum value 0, which is the maximum value 500. If it goes beyond that, then I go for another class label. Similarly, I am going to find a different class label with respect to band 1, band 2, band 3. So that is my first specific aim. In that, I have found the accurate prediction with respect to tangent go. The same procedure is repeated for another benchmarking data set, that is called a Paris data set of household power consumption, in which the same procedure is repeated. In the previous work I have done for tangent go, now I am going to do for Paris household power consumption with respect to base learner model. Base learner model means all the base learner machine learning algorithm, KNN, naive Bayes, random forest, AdaBoost, each and everything is compared with a hybrid ensemble voting classifier, which the voting classifier means hard voting, which classifier has the maximum number of votes, that classifier will be selected. So that is the main thing regarding HEV. After that, as a result of that, the classification is done with respect to band. Previously, the classification is respect to band, here also with respect to band. In order to improve the accuracy, I am going for bidirectional LSTM. Bidirectional means it works on both the direction, forward and backward direction. The meaning of forward and backward direction is it remembers the previous result as well as it uses the previous result for computing the forthcoming result. So bidirectional LSTM is one of the most predominant algorithm that is being used with respect to its long short-term memory. As a result of that, I am getting more accuracy in predicting the consumption with respect to France data set. Thank you one and all for listening my lecture. Thank you.